বিসমিল্লাহির রহমানির রহিম। আসসালামু আলাইকুম। আমাদের মাঝে আজকে উপস্থিত আছেন রেসপেক্টেড মেম্বার্স অফ রিসার্চ প্রজেক্ট ইভালুয়েশন কমিটি। কমিটিতে স্যার কনভেনার হিসেবে আছেন প্রফেসর আমাদের অনারেবল অ্যাডভাইজার স্যার প্রফেসর ডক্টর মোহাম্মদ আব্দুর রাজ্জাক স্যার, এবং মেম্বার হিসেবে আছেন প্রফেসর ডক্টর গোলাম আহমেদ ফারুকি স্যার, প্রফেসর ডক্টর কামরুল আহসান স্যার, ডিস্টিংগুইশড প্রফেসর, ডিপার্টমেন্ট অফ ট্রিপলি, Professor Dr. Mohammad Faizur Rahman sir, respected treasurer of Green University of Bangladesh, Dr. ASM Shiavuddin sir, chairperson Department of Tripoli. তো স্যার আজকে প্রজেক্ট প্রেজেন্টার হিসেবে উপস্থিত আছেন। ডক্টর আবুল হোসেন স্যার, চেয়ারপারসন ডিপার্টমেন্ট অফ সোসিওলজি অ্যান্ড অ্যানথ্রোপোলজি। তো স্যার আপনাদের সকলকে আমন্ত্রণ জানাচ্ছি এবং ধন্যবাদ জানাচ্ছি আমাদের প্রেজেন্টেশন সেশনে জয়েন করার জন্য। জিওবি রিসার্চ গ্র্যান্ট 2020-তে টোটাল 3টা প্রজেক্ট রিসার্চ ফান্ড পেয়েছিল। 3টা প্রজেক্টের মধ্যে 2টা প্রজেক্ট কমপ্লিট হয়েছে। তো আজকে সেই 2টা কমপ্লিটেড প্রজেক্ট প্রেজেন্ট করা হবে অ্যাজ দ্য ফাইনাল স্টেজ অফ জিওবি রিসার্চ গ্র্যান্ট। তো এই জন্য আমি প্রথমে আমন্ত্রণ জানাচ্ছি ডক্টর ASM শিহাবুদ্দিন স্যারকে, চেয়ারপারসন ডিপার্টমেন্ট অফ ট্রিপলি, এবং উনি প্রেজেন্ট করবেন structural damage detection on power plants using drone-based inspection and automated analysis, এবং এই প্রজেক্টে টোটাল অ্যালোকেটেড ফান্ড ছিল 80,000 টাকা। তো স্যারকে আমন্ত্রণ জানাচ্ছি প্রজেক্ট প্রেজেন্ট করার জন্য।
থ্যাংক ইউ ম্যাডাম। স্ক্রিনটা শেয়ার দিচ্ছি। I'm gonna do the presentation in English. So the main idea of our project was to develop a different system for detecting damages on large energy infrastructure, and later on, if this succeeds, to expand it for other different types of large infrastructure. So basically, this was our title of the project: structural damage detection on power plants using drone-based inspection and automated analysis. So the main work that we did, we developed and tested a unified deep learning model that works on these inspection images, basically optical images, and we also tested on thermal images. And the main idea was to have one single model that can work on both these thermal images and optical images, and also even if the inspections were covering drone images of wind turbines or solar panels, it should be able to detect the damages, because some of the damages have a very unique traits and it's common. So this was the main hypothesis that we tested, and we got some good results out of it. We also throughout this process collected some data, and also we had some of our own data, and then together we made a data set that we published in Dataverse. And we also disseminated our results to publications, participated in different competitions and workshops. And also we are now trying to extend our work so that we can apply it on other normal structure like bridges and buildings. So we are now exploring that area, and also we would like to develop a system that can not only detect the damages but also measure the severity and kind of become like a standalone application system that where we can feed the images and we get kind of a report out of it. So that systems we would like to develop, and we're working towards it. Now, this was when we made the presentation at the beginning, and we promised that we were gonna publish a data set. We will participate in the GEX 2021. Also, later on, as we were selected to be participated in recess, so we participated in that. Then we published our work in Energy Report, which has impact factor of 6.87, and also we duly mentioned the contribution of the CREET in our publications and all these competitions that we participated. Here is like just a snapshot of our paper. And now I'm gonna actually show a little bit more details into the work, what we have done. what types of results we have achieved, and how we're going to move forward from there. So the main problem that we tried to address was to detect damages that looks quite different depending on at which part of the wind turbine blade we are looking at, or even if we are looking at, for example, in PV modules, they look different. They are not exactly damages, but something that hinders the production of energy. But also this could be analyzed with thermal images like this. This is taken from with the infrared camera, and this can have a very different traits. And this is also in a very like a sharp angle where only the drones can reach and take pictures from there. So all of these, though they are quite different modalities and have presents the special relationship of the damage in a different way, but the damages that are kind of unique, a model we thought should be given enough examples, should be able to learn about them. So with that, we tried with we tried to create a unique model. So what we did, we tested with different state-of-the-art algorithms that are used normally for damage detections, but then we try to train them with our own data sets and see how they perform, and then try to find which types of architectures is more adaptable for images of these kinds. Then we tried to make some comparative study and experimental analysis of all the available models of different versions of YOLO and efficient that which are the state-of-the-art object detection model. Then we tested on some real unseen damages that we kept separate just to see how they perform and can they be used for like real life applications, and also create a data set and that we'd like to build on for our research community. Here is just a summary of the data set that we used. So this wind turbine optical images, this was where back when I used to work in Denmark, we collaborated with a company called Easy Inspect, and they used to do drone inspections of different wind turbines. And I had the option to use some of the data sets from which was taken at the D2 wind of a wind turbine that lab had. And so those drone inspection images we used. Then we had solar panel optical images, which was taken from a published paper, and they had given the permission to use them. Then we have taken some of the images of our own of some of the solar panels that we had on the rooftop in our own buildings. So we took them, and also we collected solar panel infrared images from another published paper, which is referred here. And then these are the different types of models that we tried. So basically, YOLO is pretty fast, quite efficient, but we wanted to see how the performance increases, but also in terms of the complexity. Because what happens in deep learning is we can generate a very, we can deploy a very deep model, but maybe the gain in performance is not as much compared to the complexity or the number of parameters or the number of ways that it needs to optimize. Because we are considering we have like a limited data set. So if our model is too large, it might not have enough training samples to optimize. So we tried to see how this relationship plays out. So we took this data set and we trained YOLO version 3, version 4, version 5, and also did the same for efficient D1, D2, D3, D4, D5. These are efficient that is another generation of object detection models, and it's published by Google research team, but they are quite light and could be efficient as well. So if you look at this particular table, you can see that the YOLO version 5 that gave us the best results, but the complexity, since YOLO version 3, version 5, it really, the number of parameters goes quite high. And the same is if we look at the number of flops that needs to train these types of model, we can see YOLO version 5, though it gives quite a high results and efficient. This one also gets complex, but it's not really giving us a very good results. So these types of figure we generated just to see where, when we deploy a model for a real application, maybe we can find kind of a right balance. So for example, the efficient one, or if this one, we can see that even if it's very, very light, it actually works quite well. And the reason behind is because our data set is quite small. So maybe with a smaller data set, it finds its optimum position faster and kind of gives a kind of a robust results, and which is reliable enough. But maybe with this efficient DET or efficient like DET version 2, version 3, we can have that and maybe add on to some other types of features that can help this particular model having it light, but then extend its performance in terms of the accuracy in object detection. And the same thing, actually, we have this experiment done on all the damages separately. For example, when we looked at the wind damages or only solar, when what happens when we mix solar images with infrared solar images, or solar infrared images, smaller and larger solar scale, what happened when we mixed with these large wind turbine data sets and the solar images together, and then what happened with wind, small, large solar images, and also infrared images. So what we have seen, the last one is the most complex one, because it covered all 4 modality, and in this case, which was kind of our primary goal or primary research question to explore, YOLO version 5, which performed really well. But then we can see this YOLO generation, they are really able to perform better when we compared with like a different sense of data and different scales. So all these results we actually kind of summarize and get the insights for our publication, and I think we got what was the main finding was that we know that this actually can work, and the advantage of this thing is because in normal practices we actually train models for different types of data sets all the time, but what if we now with the modern technology we can actually create one model that actually has all this information, like we human we are, because we learn so many things, but it's our one brain that learns all the things. So rather than training different models for all different applications, when we have common things to share, maybe we can train one model and just generate the right data set so that it can and have the right variability so that it can be quite robust. So that's thing is, I think it's very, very potential, but still a lot of scope for improvement, and we need to explore further for creating a more reliable application and the final reporting system. And that was it, and this is kind of just a summary of what I said. So we have these drones, we make these images, and this is where these training steps where we worked, and in the future we want to work on creating this severity reporting based on the location of the damages, and also improve our performance, and also feed into different other sensor data and create a more data fusion based approach, and also generate a suggestion system. So it's not only reporting that this is the condition or the health condition of the blade or any other infrastructure, it should be able to say, now you need to repair, or you need to repair these types of damage or this particular damage in 6 months, comparing the cost, the time it takes, comparing the severity of the damages and things like this. So we are here, and we really want to thank our Crete Green University of Bangladesh for giving us this funding and this space and opportunity to actually investigate into this, and hopefully from here we might create some kind of avenue that can actually generate our local expertise in Bangladesh for doing this kind of surveillance or health monitoring and create a great value to our economy and our industry, and create this local know-how that could be even in the future exported in other countries as well. So thank you very much. This is where I'm going to end my presentation. And if you have any questions or any comments.
Dr. Shiab, thank you for your nice presentation. Actually, you have published one journal paper with high Q1 thing. You took some pictures either by drone or by manual anyway.
Yes.
And I could not understand the graph. MAP, mean average prediction, versus number of parameters you have mentioned.
Yes,
What
sir.
is the relation between the parameters and what are the parameters you did not mention, and the relation between the error and the name of the parameters? Since you have taken some pictures, and from the pictures, you have measured those parameters and you have drawn some graphs by using some algorithm or developing some algorithm, I think. Is it,
Yes.
am I right?
Yeah, right, sir. It's true. Do you want me to explain these parameters?
Yes, just for an understanding,
Yeah, sure.
for clarification.
Yeah, so mean average precision is maybe if you maybe I will draw a little bit. So the mean average precision is basically, just a second, sir. I'm gonna draw on the board. So let's say we have a damage somewhere here. So this is my ground truth. And then let's say I'm gonna detect, so this is my prediction where this damage is. So let's say I have predicted like this. So the mean average precision, first we have to find what is the AUC, like area over intersect. So intersect over union, IOU. So first what I have to do is find, this is my overlap area and this is the overall area. And this ratio, if it's more than, let's say 0.7, then we consider it as a right detection. So that's our true positive. And then we can have a
That means you
positive.
understand that there is a crack here, is it?
Yes, sir, it's a right detection. So many times, let's say we have 10 damages and 7 of them you have detected right. And maybe some of them you haven't detected. So in me as like a precision is how many have you detected out of how many damages were there is present. It is not a straightforward, because it's like if you detect something where there was no damage, that was also gives you a penalty, like a penalty. So that's called a false positive. This is a true positive. So true positive divided by false positive plus it's called a false negative, which was present but you didn't detect. That ratio is called the precision. And then when we make an average precision, so let's say we have analyzed 200 images, and in each image we get a precision score, and then if we average it for, let's say, 200 images, then it gives like a precision. So you can, in normal sense, you can consider it as an accuracy, this mean average precision. And the more this value, it's the maximum you can reach 1. So when it's around, let's say, this region 0.8, so 0.87, I think it's quite good. And also the detection is quite, like, even the region boundary is quite accurate. And the number of parameters, this is in a deep learning model, which is actually in a deep learning model, we have millions of parameters. This is, for example, let's say this is like a linear system, and every layer has like a lot of weights that is connected to the next layer, then the next layer, then the next layer. So an image, let's say an image can have a size of 3000 by 3000, and this all of this gets mapped layer by layer. So we can have millions of weights that needs to be trained and optimized. So the number of parameters could be actually quite high.
Assalamu alaikum, Dr. Shihab.
Yeah.
I would like to ask you something. Usually, whenever we compare different models using deep learning,
Yes,
we
sir.
keep our parameters fixed because otherwise the comparison will not be fair. But in
Right.
this case, what I can see that if for different models you are having different number of parameters. Is it that you were trying to get the optimized value for that particular model or something like that?
Sir, here I think my plot is a bit misleading. The parameters here actually not in like a normal sense parameter. It's the parameter, or I call this a parameter. This is actually the number of weights in the deep learning model that I have deployed.
That means
It's
these are
not.
the layers, right?
It's the layers, right? The
Hidden
layers,
layers, right?
right?
Okay, that's why parameters is misleading to be honest.
Yeah,
But
it's a
hidden layers is
bit
okay.
right.
Thank you, sir.
Abolution sir, is there any comment, question, feedback?
Assalamualaikum, sir. These are very difficult to understand for me.
Forget about mathematics. Forget about graphs.
Overall work.
You can think about application point of view
Yes.
and the uses in terms of increasing the quality of a human life. You can think about that.
Yeah, yes.
You are a person from sociology, so you can think about
Yes.
how people perceive it and what is the benefit for the society and so on. You can think in that way.
Dr. Shiav is presenting is very nicely he is presented. And the matter, in fact, I heard these things personally from him. Also, I was asking when we were in a tea stall. So I was very happy to know these things and his understanding on this point. So I think this will help for helpful for our society, not only for our society. In everywhere it's helpful. So the way he is going ahead, I think, is very interesting. And though I am here layman, but I think the way he is presenting and the way he is very serious on that matter, I think it's a good initiative from his part. So I would like to thank Dr. Shihab. Go ahead.
Thank you.
Please.
Thank
This is
you.
my comment, sir, as a layman.
Thank you, sir. Thank you, Dr. Shihab, for presenting your work in a nice way. Also, the quality of the work that we do observe is very high. And I believe that the fund, the Green University of Bangladesh, uh, bestowed upon you is basically a worthy task, and definitely this has increased the state-of-the-art knowledge in the repository and has helped, including you, some other members of this research work, technically improving their capacity in doing this work. I am also not working in this area, but overall, I just want to make one or two queries. Like, to the best of my understanding, you have concentrated on mean average precision. That is a very important parameter for object detection. But have you concentrated on to identifying the level of damage? I mean, how severe it is, and should there be different levels of damages, and identifying the levels of damages will be directly connected to the measures that will be taken for correcting it or so. So this is my first one. My second one is I was trying to understand whether your algorithms are running in the drones or you are just collecting the images from the drones and then you are executing those images offline, or you are doing it in real time execution of your algorithm to detect it and making the decision. So time is a very important parameter here, but that will be required. So lightweight algorithms will be of high interest. But that from that point you can shed some light over there so that we will be educated. Thank you.
Yeah, thank you, sir, for very nice comments. I think this is two very important questions. So the first one, actually, this is our actually final goal, because it's not enough just to detect a damage, because in an important application, we want to know the severity of the damage and also what should we do about it. And so right now, I have created only one class, which is if it's a damage or not. But because it's just the first hypothesis or the first question that we try to answer, can we mix different modalities? And now that we can see it works, so the next level should be that even within the damage class, it's a very good suggestion that you made. We have to create different damage levels. So all of these levels should be of different class. And once a model trained, it should be able to say, okay, this is a damage, is a crack, but it's not only a crack, it's a kind of a very severe crack that needs to be, because that information should be fed into the next level reporting system and a suggestion system. And this is, we haven't done it, sir, but we would like to do this in our next research work. And we're really looking forward to do that. And the second question is, right now we are doing it offline. So a drone is taking the images, they're quite large images we collect, and then we are training it. But once we can train, like a model gets trained, and it's normally, it's just a linear calculation. Once we have learned the weight, so any image could be fed. So it's the calculation. If we have a lightweight model and it works fine, then we can start deploying it onto create a real life application that can run online on the drone itself. And that would be like really wonderful, because then we can actually in a real time, I mean, let's say, even if, for example, let's say if we even have a fire that's broke out on an infrastructure, we can send a drone just very quickly to survey that system and say, how is it safe to stay close by, if it's going to break or not. So that's kind of a open-ended research, but that would be really valuable if we can generate something like this. Right now, I feel the main bottleneck is to generate enough data set to train. But if we can get the permissions, because for example, these drones takes permission from the civil aviation, it takes around 1.5 months, the big drones. But if we can generate some really quality data set, I think we can generate a very useful application for our community, our government, and for many different systems.
That's great. I was looking into that and need to be investigated the different levels of the damage that you have taken into consideration for your future work. And also not only this damage detection, the drones can be used for many other disaster recovery applications that are highly time sensitive, and they have increasing application areas in many perspectives, even for handling some disasters related to building collapse related to any sudden event occurred in a crowded area where accessibility is a question for the ground vehicles, then we can send drones over the air very quickly and get some practical images and understanding on this scenario. So thank you very much from my side, and I believe it's a worthy work, and it will be an example for many other people in this research funding purposes. Thank you. Jinath for the next.
Thank you, sir. Sir, আমরা খুবই সরি যে আমাদের নেক্সট প্রজেক্ট প্রেজেন্টার ডক্টর আহমেদ আল মনসুর স্যার, অ্যাসিস্ট্যান্ট প্রফেসর ডিপার্টমেন্ট অফ ট্রিপলি, সাডেনলি অসুস্থ হয়ে পড়েছেন, তো উনি প্রেজেন্টেশন সেশনে জয়েন করতে পারছেন না। তো আমাদের সেশনটা এখানেই শেষ করতে হচ্ছে স্যার।
তাহলে কি আরেকদিন আমাদের প্রেজেন্টেশন ব্যবস্থা করবে নাকি
স্যার? একটার জন্য আবার স্যার এটা একটু পরে ডিসকাস করে
আচ্ছা,
নিতে
এটা
হবে।
তোমরা ঠিক করে নাও কি
হবে, সেটা একটা ব্যাপার। আর জিনাত,
জি স্যার,
এইখানে হলো ইম্পর্টেন্ট মেম্বার কামরুল হাসান স্যার রিলেটেড এরিয়াতে কাজ করেন, নলেজ আছে, তাদের উপস্থিতি আসলে নিশ্চিত করা দরকার আগে থেকে, ঠিক আছে?
স্যার
না হলে আসলে মুশকিল। আর মেম্বারই আছি আমরা 4-5 জন সিনিয়র পারসন, তাদের সকলের উপস্থিতি খুব দরকার। এটা আগে নিশ্চিত করে তারপর মিটিং কল করতে হবে, ঠিক আছে?
জি স্যার।
ওকে, তো ডক্টর শিহাব এবং আমি আরো ডক্টর রাতিলকে দেখতে পাচ্ছি, ডক্টর আহসানুল আলম স্যারকে দেখতে পাচ্ছি,
ডক্টর রাসেল তো কিছু কথাই বললো না, বোঝাই গেল না।
Good wishes to all of you for the future work.
Thank you, sir.
Thank you, sir.
আহসানুল আলম স্যার, আপনাকে একেবারেই কম শুনি।